proving that one function is the inverse of another function. And just want to remind you that that proof exists this way. A lot of people want to just switch domain and range values and prove with with particular solutions that is true. It's not enough. So the general proof would be this, would be to take a composite function and say inverse of f of x, solve that composite function, and if it comes out to be x, then you can say that's good proof of that one function is the inverse of the other. You could also do it the other way around. You could take f of the inverse of f of x, and that would also have to equal x, but we're going to do it this way if you don't mind. So I'm going to go ahead and start setting that up. First thing I'm going to do is I'm going to set up the shell here this way and say that what I intend to do is take 2 over the square root of 1 minus 2 times the value that I intend to insert, and then I'm going to go back here and I'm going to insert that this f of x. So here's my f of x. So I'm going to put my f of x in here, and that f of x is x squared minus 4 over 2x squared. All right? So I'm going to go ahead and start solving now, if you don't mind. And the first thing I think I'm going to do is I'm going to take this. Yeah, look at this. This negative 2 right here, these are both factors. So just being careful to make sure they're both factors, and they are. So I'm going to take this factor of 2 here and this factor of 2 here and cancel them out. So that's just going to do this for me, isn't it? The next thing I'm going to do is I'm going to distribute this negative sign through here and here. So I'm just going to rewrite this for some clarity and remind you that I'm taking the inverse of f of x. And that's 2 over 1 minus x squared minus 4 over x squared. Hopefully that's looking good, right? I'm going to go ahead and do that work. And if you look at it for a second, it starts to clean up. It looks like crap for a second, but it's going to clean up pretty nicely, because what I'm going to do is I'm going to partition this piece out. And what I'm looking at is this, right? I'm looking at this over this. So I have this over this, which is 1, and this over this, which is negative 4 over x squared. So as I continue to clean my math up, my algebra here, just going to clean that up. Going to be really methodical about it, because that's where you kind of run into problems. So I'm going to actually show you this work is 1 minus x squared over x squared. This negative sign is this one, this 4 is this one, and of course this x squared is this one. So hopefully you can see all that stuff. So as I start to work that out, I know that x squared over x squared is just 1, isn't it? It's just 1. I should have put my fraction bar there. I'm sorry. Subtract this. 1 minus 1 is 0. Oh, look, I should have distributed this negative sign. That would make this positive, right? So this negative sign should have been like this, and I should have distributed it into here and here, like I showed you. Here it would have made this negative. It would have made this positive, so I apologize for that. So cleaning our math one more time. We're almost done. F of x is equal to, right? It's equal to 2 over the square root of 4 over x squared. Remembering this little rule here that the square root of a over b is exactly the same as the square root of a over the square root of b. So I take the square root of 4, which is 2. See if we can see this. It's our last line right here. 2. Square root of 4 is 2. Square root of x squared is x. Hopefully you can see this now as a complex fraction. A complex fraction is just this form, isn't it? So I have this fraction over this one, and the way you solve that is to take the reciprocal of that one. So I get 2 over 1 times x over 2. I just took the reciprocal here, and these cancel, and it's equal to x. So yes, we have an inverse. This is a lot of really methodical intermediate algebra. It's very doable. I hope this is helpful. If you have any comments, please make them. If you haven't already subscribed, please do.